So today we're going to be dealing with 14.3 and 14.4, which are perpendicular lines and angle bisector constructions. We're going to start out by defining what perpendicular lines are. And perpendicular lines are two lines that are coplanar that intersect at 90-degree angles. How we would show that with a visual is we would do a vertical line and a horizontal line. And I'm going to call this, the horizontal one, line L, and I'm going to call the vertical line M. And to show in my visual that these are perpendicular, I'm going to put a box there. Notation, what that would look like is I would put L is perpendicular to M. Perpendicular symbol is an upside down T. Now we're going to go to constructions. So to construct the perpendicular bisector of AB, I'm going to start out with my compass point on B, and then I'm going to do it the other direction. I'm going to go at least halfway, and I'm going to do a big arc. Whatever arc I did from B, I'm going to do that exact same arc from A. Once I have that arc, I'm going to connect where the arcs meet. So I'm going to label this point up here C, and I'm going to label this point down here D. And I'm going to connect C to D. Now, we've just done the perpendicular bisector, which means we need two things to notate. The first thing that I'm going to notate is I'm going to go ahead and label this point that's in the middle M because it is the midpoint. Since it is a midpoint, it cuts this segment in half, which means this part is congruent to that part. So statement-wise, I would say AM segment is congruent to MB segment. Not only is it bisecting it, it's also perpendicular, which means I'm going to put my little box there to show it's 90. And notation-wise, that would be CD segment is perpendicular to AB segment. We're going to do one more of these together, and then I'm going to have you do one on your own. So to construct the perpendicular bisector of EF, I go from F, and I'm going to go a little bit more than halfway. And I'm going to do an arc. Whatever arc I do from F, I got to do the exact same arc from E. Then with my straight edge, and I'm going to go ahead and call this, I'll call this where they intersect A and down here B. So I'm going to connect A to B. If I've done it correctly, this should be my midpoint. So I'll label it M, and I've just bisected it and did a perpendicular. So with notation, I would state that EM segment is congruent to MF segment. And we also did perpendicular. So AB segment is perpendicular to EF segment. Now that we've done two of them together, I'd like you to go ahead and do number 3 with your group. When you do number 3 with your group, the segment that you're going to construct, go ahead and label that EF, and then make sure you give your notations at the end. So now that you've done that with your group, your picture should look something like this, what you're seeing in front of you. That's what your picture should look like. And those are my notations as well. I should have DM segment is congruent to MC segment, and EF segment is perpendicular to DC segment. So that's how you do a perpendicular bisector of a line. Now we're going to be doing another type of perpendicular, and that's to construct a line perpendicular to CD through point O. So I want to go from O down to CD, and I want it to be a perpendicular. And I can't just eyeball it. Anytime it says the word construction, it means that it's asking you to only use a straight edge and a compass. So this right here, that word means straight edge and compass only. So how we're going to do that is we're going to put our compass on O, the pointy part on O, and then from that part, I'm going to do an arc that's going to hit that segment twice. So I'm doing a big swinging arc, and I want it to hit that segment twice. Does it matter how big that arc is? No, as long as it's hitting the segment twice. Once I've done that, I have 2 points here, these 2 points right here. And from those 2 points, I'm going to do 2 more arcs. So I'm going to do 2 arcs down here. So I go from that point there, do an arc, go from C, or over by C, sorry, that point over by C, do another arc. What I've just created is I've just created where they intersect. And I'm going to take that point right there, and I'm going to call that M. And I'm going to connect, using my straight edge, O to M. If I did it correctly, I should have a perpendicular line. So notation-wise, I would state that OM is perpendicular to CD. Now, it's not bisecting it, it's not cutting it in half, it's just making a perpendicular. So for this one, I only have the perpendicular. So as you see, we only have the perpendicular. We don't have the congruent symbol because we don't have the midpoint. So now we're going to go ahead and we're going to do one more. So I want to do the perpendicular to FG through Q. So I'm reminding you one more time what that means. I want to go from Q. I want to hit FG twice. So I'm going to do an arc. It's going to hit it twice. Once I have that arc and it hits it twice, I go from where it hits, do a little arc down below, from where it hits, an arc, and I should have the arcs meet. There's my point. And I'm going to connect Q to that point where they meet. And I'm going to go ahead and call this point R. If I did it correctly, this should be a perpendicular. So my notation would be that FG segment is perpendicular to QR segment. Now what I'd like you to do is on your own, I'd like you with your groups to go ahead and do number 6. I'll put the answer up in just a little bit. I want you to go ahead and try that. Now, as you see, this one's a little bit tougher because of the fact that we hardly had enough room to be able to draw our arc. You could always extend your line to make your arc so that it hits a little bit better, but I was able to make it fit, so I didn't need to do that. I went ahead and labeled this point down here T, and I'm going to go ahead and give my notation statement would be to say FG is perpendicular to QT. Once we've done that, we're going to flip it onto the other side. And now we're going to be dealing with angle bisectors and angle constructions. So in order to do that, we're going to start out by defining what is an angle bisector. And an angle bisector is a ray, line, or segment that cuts an angle in half. Now, when I say half, it has to be congruent. So in other words, it has to be into 2 congruent angles. So a visual, if this is my original angle, and we'll call this angle A, this ray is cutting it in half. Now, in order to show that it's cutting it in half, I have to use more letters. So I'm going to use a C, a B, and a D. And it's cutting it in half, which means that this angle right here is congruent to that angle right there. So I mark them as congruent. My notation would be to state that angle CAB is congruent to angle BAD. Notice A is the vertex, so that's the middle letter. Now we're going to actually construct an angle bisector. So how you construct an angle bisector is you start off with your point of your compass on S. Make my compass a little bit smaller. On S, because that's my vertex. And I'm just going to draw a big arc. My arc's going to be big enough that it's going to hit both sides of that angle. Once I hit both sides of that angle, I'm going to go from that intersection there, and then I'm going to go from this intersection here, and I should have an X. So I went from both of these 2 points, and I'll call those A and B. So I went from A, did an arc, from B, did an arc. You have to do the exact same arc from both. Then where the 2 arcs meet, I'm going to call that, I'll call that C. And I'm going to go ahead and use my straight edge, and I'm going to go from S to C, and I'm going to do my ray. It's going to go from the vertex S through C. There's my ray. That ray just cut this angle in half, which means both those smaller angles are congruent. So I'm going to go ahead and state my congruent angles. So I have angle ASC is congruent to angle CSB, because we have 2 congruent angles. I'm going to do the exact same thing from number 8, and then I'm going to have you do 9 and 10 on your own, and then you'll be able to check your answers. So I'm going to start out going at B, and I do an arc. It does not matter the length of your arc. Makes no difference. I could do an arc way in the middle here. I could do it way down here. It makes no difference. Then I go from those 2 points where it intersects, and I'm going to do little arcs out here. Right there. Right there. So right now I have this point. I'll call that A. Over here, I'll call C. And I'll call that D. Doesn't matter what you call it. And then I'm going to go from B to D, and I'm going to make my ray. And it's okay, it's going to go into the other part that we have up there, and that's perfectly fine. It's a construction. And I just bisected the angle. So these 2 are the same, which means I have angle ABD congruent to angle DBC. Now, when you're bisecting, if you state congruent, you don't have the little m. I could write it like this, or I could write it like this. The measure of angle ABD is equal to the measure of angle DBC. When you're using the little m, you're talking about the degree measure. If you're talking about the degree measure, then you just have an equal sign. Otherwise, it's perfectly fine to put as congruent. Now, with your groups, you're going to go ahead and do 9 and 10. I'm going to go ahead and do those here as well, and you'll be able to see the answers once we go back on. But I want you to go ahead and do 9 and 10 with your groups, please. So now I went ahead and did my constructions. I'm going to go ahead and label them now. So I'll call this B, this C, and I'm going to call that D. And I've just bisected it, so these 2 are the same. And I'm going to state that angle BAD is congruent to angle CAD. Depends on what letters you use. You just want to make sure that your vertex is angle A, and that's going to be the center letter. Now over here, I'll just call this E, I'll call this F, and I'll call where they intersect out here G. Same thing, these are congruent. So then I have angle EDG is congruent to angle FDG. The only thing we did on these is we did an angle bisector. Now your homework tonight is going to be doing all of these, and it's going to actually be adding it to a triangle. Hope you have a great day.